Hi, I'm Randall Barney. We're here at the NAB show speaking with teleport, satellite, and technology providers about their customer solutions, and here's what they had to say.
I believe first and foremost was DVB-S2. I think that coming together, first of all, HD, the need for additional bandwidth for TV content, as well as a new standard that, let's say, was at least 30% more efficient, I think uniquely set a pace for people to, at the same time, change their set-top boxes or DVB-S2 modulators, and at the same time change the encoders so that you can receive additional channels. So you have a true motivation for a change. I think many technologies come out, but if there is no motivation from the part of the customers, then they will not get implemented. And I think the true calling is when you have a technological innovation that also gets implemented. I think that's the main thing. An important customer of ours approached us. They distribute content all over the world. They distribute, for example, the last football finals, the next Olympics, and other type of contents. And they ran a C-band full transponder, and they wanted to double the capacity without having to buy new satellite capacity. So basically, they achieved this with NovelSat NS3. They basically went from DVB-S at that time to NS3, and they were able to transmit twice as many channels over the same full saturated transponder without incurring additional satellite capacity cost, and also without incurring additional costs to their subscribers, which already had antennas and were already looking at this specific satellite. So you achieve advantage for the customer on one side, advantage for the content delivery, and as you probably recall, they came out with HD, you had to have every channel both in SD and HD, so it automatically created a large amount of requirements for data. In the process, we've continued to improve the technology, but this is, I would say, a perfect example of how somebody can take a new technology and bring it to its advantage. I'd like to point out another example, for example, that we did for another customer in Latin America. New technologies come out, but people don't want to necessarily immediately change all their existing equipment. And so they had existing IRDs, a bunch of them, a ton of them, and they were looking to benefit from higher satellite efficiency without necessarily replacing their previous equipment. So what we did is, previously the IRDs were connected DVB-S to the satellite and receiving content. We basically connected their existing DVB-S IRDs to one of our ports, and then used our modem to transmit more efficiently using NS3. So virtually they were able to double the capacity on the satellite without having to replace their existing equipment, and being able to add more channels and add new IRDs for HD or 4K in the future without having to replace those that don't require replacing. I believe that what we see right now with our customers is that the traditional broadcasting unidirectional transmission, one modulator, one receiver, one contributor, SNG, and the receiver on the other side, is being changed by different needs. The first need is you now have both IP content as well as ASI, as well as high definition video content, and you want to have a dual channel capability so you can transmit both video and IP content. It can be from those helicopter cameras that are flying around, or any device that gets attached to a truck. The truck today is not just only a satellite truck, but has Wi-Fi or other means of communication, and it has wireless cameras, drones, helicopters, and some of this content is already IP streamed content. We have an important customer that right now is switching for most of their content to streamed content. So basically within the truck or vehicle, they accept all the cameras, they build a streaming and they transmit over IP. And they still have other cameras where they're transmitting video, so this dual channel will come. The other thing we've seen more and more right now is that this unidirectional communication not only becomes two channel, but the IP channel needs to be bidirectional. So if you previously had a modulator, demodulator, now suddenly you want to be able to still transmit data, IP and video data, but the people in the truck want to be able to view the stuff they're sending over. They want to be able to use the internet or chat or use voice over IP to speak with people on the other side. So reporters want to transfer their scripts or other additional nodes they want people to have on the head office. So what we feel is that this unidirectional traditional means of communication will be now a mixture of partially unidirectional content, partially streamed IP content, and then bidirectional IP, just doing any things that you can do in IP. So I think this is one of the changes we see coming along in the industry. When we look at the broadcasting satellite, I mean, that's the field we are involved in. We already mentioned that traditionally it was unidirectional communication. One person transmits, the other receives, the other way around, contribution, distribution, just roles change, but the same thing. As we go into bidirectional communication, now your satellite bandwidth needs to suddenly be able, you need to allocate bandwidth for both, for three things. You have your video transmission, you have your streamed IP content, and now you want to have bidirectional transmission. But all the video streams have been unidirectional by nature. One of the things that we do is we have carrier echo cancellation, or we call duet, so we can bring in inbound carriers under the big broadcast carriers without having to add additional bandwidth. What I would like to see is this technology is being somehow adopted and made more available to customers so that they, let's say, are not scared to implement new things because today they don't want to touch their broadcast streams or whatever. And you know, as we see, when there is a need, the technology adapts. So as there is a need for bidirectional communication, the ability to do it without having to buy additional bandwidth, I think is going to be a major contributor to how these things operate.